Welcome, everyone, to episode 7 of the Manufacturers Podcast. This week will be part 2 of our two-part series on 3D resin printing. Last week, we discussed the different types of machines and how to get into resin printing. This week, we're going to continue on by making some parts and discussing that a little further. Hope you enjoy. Welcome to the Manufacturers Podcast, the only source to bring you raw, unfiltered experience from those in the manufacturing and skilled trades world. If you are looking to learn and develop your skills, you found the right place. Strap in and stand by. Welcome, everyone, to episode 7 of the Manufacturers Podcast. So, as you might know, we were started out with 3D printing last week on resin machines. Now, before we get started with the podcast, I just want to say, as you all know, it's no surprise about the things going on in the world today, especially in Ukraine. Behind me, you'll see we're flying the Ukrainian flag in thought and prayer and just holding all of those people, in our mind, just hoping that this all comes out on the better end. Living here in the U.S., we take a lot of things for granted. And being we have one of the most, powerful and strongest militaries, we don't always, worry about what happens. There's no nation that can really threaten us. They can say things, but, when it comes to it, we've always backed ourselves up and we can hold our own. You have a country like Ukraine who nobody gave a chance, nobody thought, stood, a snowball's chance in, the downstairs to survive an attack and an invasion from Russia. And here we are nearing a week into this, day 6. And the Russians haven't been able to take any city and they're being repelled. So, I know this has very little to do with manufacturing, but we just want to take a second to thank all the people over there and how patriotic and devoted and, how much they love their country to be fighting. Men, women, I'm sure there's even some younger children, teenagers that are taking up arms with whatever that is, rifles, homemade explosives, whatever. They're going to fight back to the bitter end. And that's something that, here in America we should see. It's all over the news, and just watch and, take something away from that. Whether, it's being devoted to anything you do. It doesn't have to be defending your country. Anything you do it with passion like you saw. Moving on, this week, we're going to get deeper into 3D resin printing. And last week, what we did, we kind of went over the system and how to get a machine and what you would need to get set up to do that. And this week, we are going to go a little bit deeper and we're going to pull up some of the software. I have things prepared this week and I don't have anything else going on my computer, so everything should work fine. I have the machine is set up. So the same machine here. We have some resin in it. The build plate's all set. It's ready to go. So all we have to do is prepare our models and then load it up and hit print. And then while it's printing, we can, continue the discussion. So what I'm printing is I have one here. I did a preliminary model and we had to make some changes. It might be hard to see, but we'll have some photos up on our Instagram page. This is an LED tool holder or like a diode holder for a custom built transformer like action figure. I believe that's what it is. Something very close to that. This is for a coworker of mine, a very talented machinist and CAD person, and he's building a one-off, a custom transformer, Power Ranger droid, Zord, whatever you want to call it. And he has little button LEDs. Now you can't see it on this from here. You'll see it on the pictures we post, but there's actually wire grooves so he can wire up his LEDs, and those will hold it, and he can, from there project color wherever he needs. So we're printing this out of a clear material, and it doesn't have optical clarity. It's a heavy polymer. Has a slight tint of yellow. That's just its natural state. But it's a very high performance polymer that's normally used for flex additive. It's meant to have dye or pigment put in it. But we're going to print it straight out of that material, and it's a real good material to use. So we'll get into that. But first, we're going to kind of dive right into the CAD, and you'll see the part here. We're going to bring it up on Fusion. I have SolidWorks open. That was the native file of the part I had, and I also had the STL. But we're going to work in Fusion, and then we'll bring it over into our slicing software. So essentially, what I had to do is this part, as you can see here, I'll bring it up. So this part, I know for you listening on Spotify or the non-video options, you'll just have to check the Instagram, and you can kind of follow and see what we're going to be doing here. But for all of you watching, this part here, essentially, you'll see these triangles on the surface. So this is already in a mesh format. All right. And even when I rotate it, you can see. Now, you'll wonder, these floors in the ceiling, those are, don't have the triangles, or they're not turned into an STL or a mesh yet. I did some modifications. So this part was drawn in SolidWorks, and its native file type for SolidWorks is a solid part, or the extension would be .sldprt. And then it was converted into an STL, which is what's needed to manufacture this on a printer. And all I had, this was emailed to me, and all I had was a STL file. Now, if you bring an STL file in, you'll see all these triangles, and normally there's not much you can do. Let's see if I have I'll open it. I'll see if I can open the original file, and you guys can see. Holder clear. I believe this is it. Okay, so here's the STL file that was sent to me. As you can see, it still has all these triangles, but when I hover over it, it's selecting a whole body. So essentially, it's recognizing that as one object. And the problem is, if I need to modify this, well, how do I do that? So this will be a little quick Fusion lesson. But essentially, I would have to convert this into a solid body. Now, you won't be able to get rid of the mesh. That'll still be there, but you will be able to edit it. So if we go back to this file, I did convert that to a mesh. And now the floor here, if you see here's a little design for manufacturing situation. These are the cutouts for the LED. Now, when you print with SLA on a machine like this or any other of this in this class range, generally when you have a flat surface, 90-degree parallel surface, you get a lot of tension. And now this material is in its green state, so it's soft when it's printing. And your tension between your FEP release film. So if you remember, there's a vat or a tank that has resin, it's filled up, and the build plate submerges into the resin. The UV light cures that layer, and then the build plate will rise up. So it has to build plate. The material is stuck, or adhered to the build plate and slightly to the film. Now the film is designed for it to release, but there is a little bit of force from the curing and from the hydraulic suction. So on a flat surface like that, you will get taper. It kind of tugs at that surface or pulls it. So what the issue we had here is, now this surface here was not an issue. The orientation this was printed was this surface here, this bottom, this part, that was against the build plate. So theoretically in the tank, it's going to be positioned like this. And your build plate would be here. So that surface, that we just showed you, this surface was affected as well as this surface. Well, the problem is, we can't have that because we're trying to print a part. So what we have to do is put a taper on that surface. And you can't see it here. I wish I could show you guys. But there's a taper there. It's a little bit of it's got a slope. So we need to compensate for that. Now, the one thing that the machine can do is print on an angle. So you put any angle, even 5 degrees, and that now it's going to have a small surface area as it works its way up that slope. And if it does happen to pull or tug a little bit, our hope is that it will end up flat like this. So we're kind of compensating with our design. And these are the things that we lump into the category of design for manufacturing. So when you're 3D printing, and with resin in this case, anytime you have a substantial 90 degree or 85 to 90 degree overhang, you really want to look at, can I change something on this part to eliminate that, or if not, can I compensate? So it brings me back to our original point where I had to edit this model. So to edit this model, I had to convert it. So in the surface, we have surface mesh form. So in the mesh workspace, we have in our modify group, we have convert mesh, and it will turn it into a solid or surface body. So that's what was done here. Then I went in and I created a construction plane at an angle to this line. It's going to default to 90 degrees, 0 degrees, 0, 90. So I type in 95. And as you can see, this plane slopes downward. I created that plane. I then created a sketch on that plane. And instead of having to draw anything, what I did was simply select these triangular facets. Then I would go to create, and it's not here. If I go into, because we're not in the sketch mode. So if I sketch, you'll see create, and we have project. So I selected those edge lines and the triangles, all the triangles that went around here and made up this pocket. I selected all of those and I projected them onto my sketch. And then from there, I was able to do an extrusion, an extruded cut, which removed that material. Now you can see there's a tapered pocket there. So that's how I got that taper in there. I did that all the way around. And then the top, because I'm printing with this adhered to the build plate, due to our burn-in layers, which are overexposures to ensure adhesion to the build plate, I had to add 50 thousandths worth of material. Then this part, when it's cured, it can be chucked up into a lathe and we can face that off. We'll get rid of that burn-in, or that what they call an elephant's foot. And if you look everywhere else in this model, all the other surfaces are pretty good. It was just these. It's a smaller area, So there's not a lot of, it doesn't necessarily cure so much. And you have this open area, and in that layer, you go from nothing, and then that whole solid layer, the whole face, from then on out, it's essentially solid down to here. So it's a lot of tension. But moving off of that, uh, that's kind of the setup that we have for this part. And we're gonna print 5 or 6 parts, maybe 7, 8 of them. I'm not exactly sure how many my friend needs. I just print, a handful of them, and that way you lose one or one gets marked up in the chalk or you chip it or something, you're good. So we're going to kind of get deeper into the setup on this. And I know last week we got some parts running and I didn't have a lot of files prepared. I had a lot of things going on. I was trying to figure out the video. I think I got that down pretty decent now. I use what's called OBS Studio. So you basically set up your scenes. So like our opening scene, when I give an introduction and we play our intro music, that's on one scene. And I have to control it here. I don't have a Jamie. If anybody watch Joe Rogan, he's got young Jamie. I don't have a Jamie here. It's all me. So I have to start the recording. Then I have to, have the artwork in that scene. I have the recording. I have to play that, and then once we transition, in the software, essentially one side of it, I can see my preview. And then I transition over to this side, and that's the live feed. That's the recording. And I have all my inputs. So I have the microphone, I have the video capture, I have my window capture. So like when we were just looking at Fusion, I have to have that program open and it linked into OBS so I can, and then I have to set, I can set it where it covers the whole screen or it covers some of the screen. And, so it's a little bit of work. I'm still getting used to it. I think I'll get better as time goes on. But I just wanted to get some video onto this. And then I still have to go, for anyone who's not familiar with podcasts, it's not as easy as just buying the equipment. I mean, anybody can go buy a microphone. Anybody can, if you have a Mac, anybody has GarageBand. You can actually use an iPhone to record video. You can get a mic and an adapter, XLR adapter, and you can plug a microphone into your iPhone. There's a lot that goes into it, and I'm still learning, just like with manufacturing. But I think I'm getting better. I'm obviously no master at this. Just trying to bring the best content I can for what we're doing here. So moving on, we just went through Fusion. I kind of went through the preparation of the model, what I had to do, and we discussed that. Then once we're going to, get ready to slice this to bring it up, what you'll see is, in any type of 3D printing is a slicing software. And like we mentioned last week, you have to break down the model, into layers, and it's on a thickness. And each layer will add up, to the completed part. And there's parameters, there's settings for the machine and for the material that we're using and whatnot. So, we'll go over that. I'm going to be using the Anycubic Photon Workshop. That's the native software that comes with the machine. There are other slicers such as Lychee and Chitubox, which I have now set up. But these models, there's no supports. And the only reason I would use the other softwares is because their support generation and creation is so much better. But I'm printing these right off the build plate, so and they're simple. There's no reason to use any other software. So as you'll see, I'll bring this over here. This is Anycubic Photon Workshop. And you can see here it says Photon Mono X6K. That's my machine. And this represents the build plate, the workable area I have. So if we go back to Fusion, we're going to create an STL file, which is not very difficult. Let's do that real quick just to show you. So now I have, this is solid. I want to make it an STL. I just can go to Utilities, Make. This is 3D Print. I'm just going to select the model and hit OK. That's going to let me save it to whatever directory. It's very simple. So if we go back to Photon Workshop, I have my STL saved. Now I've went ahead and prepared the scene, which is essentially it's all the parts that I want to print. So I'm going to open the scene file. I have it here, holder. So I got 10 of these things. And you can see, they're all set, they're all ready. Now my model has one little blip to it. That little layer, I'm not going to worry about that. It'll just consume that up. And I filter the resin out. STLs, sometimes they're a little tough to get those extruded cuts, but the part's going to work for what I need. So you can see there's wire grooves here. So this will plug in to a socket, a pin. The wire will run in. You have for one LED, 2 LEDs, and the third one is right here. We're going to be printing flat to the build plate. So now this material is made by a company called Soraya Tech. They make a little bit higher end resins for your home and hobby use. And it's their model of resin called Tenacious, which is a flexible resin. And it's kind of meant to be a flexible additive. You can add it into other resins. Now, photopolymers, not to get too deep into the science, because I don't exactly know it all myself, but with any type of polymer, poly meaning multiple, you have monomers. Now monomer, it's a single chain, and to create a polymer you have to have a cross-linking action. So essentially, if you think of you have electrons and photons and all that, when they want to be grouped in a certain number. So, and if they're even, a monomer, it's 1. So they need to be able to attach to each other. So you have to have a chain. So when you attach a couple monomers together, you get what's called an oligomer. Now, an oligomer is what makes it possible for polymers, but to finalize that chemical reaction or that bond, you need what is called a radical, something that has like an odd number of electrons that will allow it to attach and create a polymer. It'll create a whole particle. So that's what is called, the radical is a photoinitiator. When it hits UV light, it becomes excited. It gives off its electrons. They all attach. And a process happens called cross-linking, which all of these monomers and oligomers start linking together. You get solidification. That makes a polymer. That's the dumb man's explanation about it. But this resin in here, all resins work on that premise. Most of them have a lower oligomer or polymer content, so they tend to be brittle. The more polymer, they become more flexible or more durable. So when you have fewer polymers, your bonds aren't as strong. Your materials actually becomes brittle. So you can take this material, this tenacious material, and you can add it into other polymers, and that's generally why it's kind of clear colored, so it won't change colors of other resins, and it gives it a little bit of a flexible additive property. Now I do it 10, uh, 10 to 1, so 10 parts base resin, 1 part tenacious. You can go higher, then you start getting too flexible, and then you lose your rigidity properties or your strength properties. So it's kind of all science experiment. You can play around with it. Now you can print the material straight. It will totally print by itself. It's a little soft to start with until you cure it, and then it does harden up. It's very durable because it's about 60 Shore D. So now Shore is a hardness rating for plastics and polymers, rubbers. When you get into like metals, other isotropic materials like metal, then they go on to a scale called Rockwell or Brunel. But this uses Shore. This is Shore D scale. Rubber and soft plastics generally are on the A scale. Now, like 95A, 80 to 95A would be like a really stiff elastic polymer or like a urethane. Now, like a tire on your car, it's kind of, it would be in that range. But now this is a hard plastic, essentially, when it's cured. This is 60 Shore D. The other ABS materials I have, like engineering materials, are 80 to 90 Shore D. And not to get too deep on the, the nerdy stuff here, but essentially, this material has a lot of polymer in it, so it needs more cross-linking. It takes more cross-linking to fully cure it. So that's where settings would come in. And, if I curing a economy or what we call a drafting level, like gray or lighter, like a greenish color resin, I could print much faster. I need to irradiate or expose the resin less at a shorter exposure time to cure it to its proper hardness. So this machine uses a UV array of LEDs. There's 40 of them, and you can adjust the UV power, which is essentially the intensity or the irradiance, how much UV light it puts on at a single layer over a certain amount of time. So it can vary by using more or less LEDs in each exposure. So once we put our material in here, we have our model. Now we're going to do our slicing. So we have the slicer here, as you can see, and I have the settings. So you'll see I have settings. I can choose my machine. Here I have my resin. I created this profile. Normally, I use another software that I have all my resin profiles in, but I have this one set up. You can see this is just basic information. It will kind of give us a cost estimate, but this is the majority of it here is the slice parameters. So you can see we have layer thickness, exposure time, off time, bottom exposure, bottom layers, anti-alias. So this is the first row we're going to set up. Layer thickness, we're running 0.05 millimeters. That's roughly 2/1000ths. That's very common. This is about the most common layer height, and that's a very good layer height to work with. It can go more accurate, but sometimes it doesn't always work out better. Normal exposure time, so we have 2 seconds. Now, we are going to change this to 2.3 seconds. So this material needs a little bit longer exposure time to fully solidify. See, now our default resin has some of the settings for this already. I just didn't copy it yet. So off time is 1 second. So when this machine, because the build plate is so big and there's a tank full of liquid, when it drops down, or what we call retracts down, we have to uh, allow it time for all that resin to normalize to settle. There's going to be a lot of tension. You know, you're kind of squeezing something down very small. So once the build plate reaches its, its depth, we want to give it a little bit of time before we kick the UV light on. Our bottom exposure, so this is what we'd also refer to as a burn-in layer. And this is intentionally overexposing this layer to ensure that we get adhesion to the build plate. This will create an elephant's foot, the flared base that you'll see on a lot of the parts or the supports. It's generally why you don't print off of the build plate. You would have to add extra material to sand or machine off. But that is the setting. It's normally we run about 23 to 25 seconds. Again, with this material, I want to make sure I go a little bit more. Bottom layers, that's just the number of layers that we're going to use on the bottom. Anti-aliasing. So anti-aliasing is a tool or a resource. It manipulates the resolution and the edge quality of the print. And what this does is it will help remove any layer lines. So each layer, you might have little inconsistencies. What it does is you'll see anti-alias, and then it says gray level and image blur. So what this will do is it will essentially remove some of the pixels, or it'll kind of like taper them or give a little shadow to try to smooth them out on a very minute scale. So, and that's kind of used if you want a lot of detail, then you want those set very low, or if you want it to be nice and smooth, you can set them high. And the rest of the settings here, let's bring it back up real quick. So the rest of these settings, maybe I can pull this screen up. Maybe I can just shut this off without having, and I can still look at it here, and I can kind of talk you through it. There's really no need to go too deep into these settings, but just so you understand kind of the function of the machine. So it has a Z lift height. Z-axis is the movement up and down. There's lift heights and speeds. So as you have to separate from the film, and when it does, it kind of lifts the film up with it until it separates, and it has a little bit of a concave or convex type shape. So you want to lift it slowly. You don't want to pull it too rapidly. So you can set a speed and a height that it will lift to, and then how fast it returns. And if I have a lot of surface area, like a big part, and it returns down, I want it to go slow, so it gives time for the resin to kind of ease out throughout the side. And if I have a hollow part, then I need to actually put a vent hole, which you can model a hole into the part or add one with your slicer software that will allow the material to roll out the side, and you don't create any pressure or vacuum. And the rest of these are just, this kind of advanced control. I can really fine tune it. It'll come up to 2 heights and then back down. So we'll just save that. Those settings, I had them already pre-established. Now we're going to slice this. So as you can see, I'll slice it, and when it's done, I'll show you what it outputs. So let's call this holder -1. All right, it's going to slice it. So it's going to take a little bit of time. There's a lot of computing that has to go on. As you can see, as soon as I hit it, my SolidWorks Resource Manager popped up again. I don't know if you guys can hear that or not, but on my screen, I have SolidWorks open in the background. And yeah, That keeps popping up. I apologize for that. Let's see. I cannot find SolidWorks here to show you guys what's going on. So I'm just gonna close it because it's annoying. When you use slicing softwares and different CAD, some of them like Fusion use a lot of CPU power, and slicers will too. Other programs like Mastercam or SolidWorks, or even like topology optimization, they will eat your graphics card. So you really, if you don't have a big, powerful desktop, I have a pretty solid gaming laptop here. I mean, it's got like 32. Uh, I got like a 32 RAM card in it. I can run twin 60 or twin 32s up to 64 gigs of RAM. Uh, I have a 500 gig solid state drive and a NVIDIA GTX 1650 graphics card. Like it's only an $800 laptop, but I got it for school and CAD work. It runs everything fine until you get about 4 of those programs open. Okay, so let me bring this back over for you. So I don't know if you guys can see this. Maybe it's not going to bring up the little side window for Photon Workshop. It's a little pop-up, but basically it's telling me that this print's going to take 1 hour and 20 minutes estimate, and it's going to use 11 milliliters of resin. I know that's a lie. I can almost guarantee that's going to be a lie. This new machine, because it has advanced controls, the software that just hasn't caught up to it yet. So essentially, all we have to do now, we have the USB drive that comes with the machine and it's formatted. We just got to slide it into the machine. And I'm going to scroll down. Oh, for some reason it didn't read this yet. Here. Make sure it was there. Sometimes with this machine, when I had it powered on, and I pulled the USB out of it. Sometimes it takes it just a minute for it to kind of. There we go. Holder -1. We should just waited and let the machine run it. All right, yeah, it's on there. Okay. Make sure it's not picking up the files here. Just power the machine off and back on. Generally, it will pick up the files as soon as I stick the disk in. Here we go. That's all it was. Holder -1, PWMB. Select. Machine's going to settle. There we go. You guys won't be able to see it, but on the screen here, the digital display, there's a touch screen and you have a print menu and a system and a tools menu. And all you do is select print and then you scroll. It actually has like a little icon display of your parts with the name of it. You just scroll through it, you touch it, and then hit it has like a little play button like you would see on a audio software. And it goes, and then I can actually adjust it. It has a little so you know what happened? I'll show you guys. That's okay, I can restart it because it was only did one layer. I forgot about this. It might not show you guys because of the settings. And I had on the advanced settings. Um, I don't think it's going to show you guys the settings, but I actually had a couple values that were set on 0. So this is a good lesson here. Podcasting and making videos and trying to post stuff out are a little tough. Now I could actually adjust it. I can right on the machine, but I don't have enough time. So Z lift height. So we're just gonna change this to the basic control. We can run advanced. All we have to do is it has some 0 values, so it comes up. It's looking for like a Z lift height. So I can just put in 4 millimeters lift speed. I can go 2, retract speed 3. Let's see, 1.5. Go 4, 2, and 3. There's like it'll raise up a certain height, then it'll go more, drop down. So I have these values all set. I forgot some of them were set to 0. I had my other printer set up. It's an older anycubic machine, and the problem is it doesn't have those advanced controls. So we'll just reslice this real quick. It won't take very long. It's a pretty basic file. Yeah, my other machine doesn't have the advanced controls, so it won't put a value in there. It kind of defaulted. So we'll just let this slice again. But anyway, that's all. That's all there is to it. It's not real difficult. I know you guys might think it is because I keep making mistakes here. It's 12:53 a.m. So, real life manufacturing. I have an almost 8-month-old son. Married, have a household. I get done to work around 6 o'clock. I got an hour commute back home. I have to do the whole family thing. So I'm down here in the middle of the night making videos with you guys. But I love it. I wouldn't have it any different. And, we're going to get better at this. I've got some more YouTube videos ready. I haven't uploaded them yet. We did a couple Fusion videos and a Mastercam video. And we have a special topic. We maybe get another video, another podcast out before the end of the week. We're going to be talking about a different type of software and some really cool modeling, and we'll go through that. And we'll actually print another part. All right, so this is done. It gave me the same output. Yeah, I know that. Okay, guys. So the only reason I'm able to get away with this, it printed the first layer. And I'm going to come right back and print this. So it's going to start basically in the same spot. And you can see here in the corner, it's dropping back down. It's going to settle back in. So it's going to reprint that layer. So I'm definitely going to have this stuck to the plate really well. The only good part, there's like 50 thou. That doesn't matter. It's going to get shaved off. So we're good to go now. But, the other part of resin printing we didn't really get into is the post-processing. So now this part actually is not done post-processing. Once your part is printed, you need to first wash it. They use alcohol between 90 to 99% IPA is preferable. 70% IPA will work. Or they have called mean green or some type of green citrus cleaner. That will work. And then you also have water washable resin, which is okay, but it's not desirable. A lot of times you get cracks and defects because there's kind of different solvents already in the material. So once the part is done printing, I need to take it out and I put it into a bucket or a wash station, and I clean the resin off it, all the excess. I remove it and I need to let it air dry. You can hit it with compressed air. You can put it in a cloth and shake it around. Get and then let it air dry. You do not want to let it air dry outside because sunlight will provide there was UV light from the sun and it will start to cure your part. It is very important that your parts are dry before you try to cure them. Generally, this material here, tenacious, you can actually cure it submerged in water or glycerin. Generally, you need to wash your parts and let them dry because you can. Part of the way IPA and alcohol works is it has a flash off, and when it's wet, there can still be, underneath of it. It's not quite ready to be exposed. So you need to let the alcohol dry off. Once it's dry, then you would need to put it in front of a UV light that has a wavelength of generally 405 nanometers. That's near the spectrum of visible UV light. You'll see it kind of like the bluish purple. There's a couple different types of resin photopolymers. You have 405 nanometer wavelength and then 355 nanometer. That's just the rating of the UV. That's the wavelength of the UV light at which it will cure. It'll do its cross-linking. Generally, you would cure for a specific amount of time, 5 to 10 minutes, and sometimes under a temperature. It could be 120 degrees Fahrenheit, like 60 degrees Celsius. There's a few different ones. And then your part will be very hard plastic. Now, if you print with supports, it's generally best to remove supports before curing because then your material becomes essentially more brittle or hard. And with supports, we saw those parts last week. You kind of have like a stem, and then it'll have a contact point, and you need to clip that off. And I'll show you guys what we have here. So the ideal tool are like these little set of clippers, and they're like a fine tip, and then you can really get in and clip it close and leave just a little stem that can be sanded off later. So if you're printing with supports, you definitely want to get a set of clippers. I got these off Amazon. They cost like $6, more than sufficient. The other tool that's good to have, everybody has these in their house, a pair of nail clippers, and then some razor blades. You can use those to, your clippers to get most of the supports. The nail clippers, because those have a curve, sometimes I find they work well for round parts. You can come in and get it really close to a round part without scratching it. And then the razor blade, for different uses, you can, sometimes you can reach into holes and kind of pick the support or whatnot. So, they all have their uses, and, having some good tools, have a clean work area. You're going to need lots of gloves too. That's about it when it comes to resin printing. As far as, we're going to go for now. I think we're going to try to do some like design for additive manufacturing sessions or some episodes where we talk about, if you want to build something, some considerations you need to think about. But moving forward, I know we were trying to get a guest on here, and the guest I really want to have, a good friend of mine who's got some great stuff to contribute. He's very busy right now with his college courses. He's a professor, and he's taking on a new CNC machining class, which I've been helping him with. So we'll hopefully get him on here soon. I have a couple other friends. I have a coworker. Disclaimer, I won't be talking a lot about my job. I prefer to be nondescript about what I do and the specifics. I mean, I did do precision sheet metal work and some CNC machining. Now I do composites and engineer materials, as well as uh, kind of collaborate with the additive um, efforts where I work. Uh, just the nature of the institution and my job and everything, I prefer not to talk about it, nor would they want me to. And I really want to be able to do the podcast for you guys. So I'm kind of reflecting on all my past experiences, and any of my coworkers I bring on, it will be that as well. And you know, I really look forward to what's coming up. And you know, I know this is a new podcast. I'm not very good at it. You guys can all laugh. You guys can say whatever. Um, but it's something I wanted to do for a long, long time. And I finally just said, you know what, I'm going to do it. And I didn't buy great equipment. I've got, you know, basic podcast equipment. So I have a Sennheiser mic, which is it's a German-made microphone. It's probably the nicest piece of podcast equipment I have in here. Um, I did a lot of research, and I didn't go and buy the stuff that a lot of people have. I bought what I thought I could use, what I could would be sufficient. I'm in my basement. I mean, I've got a table. I've got my computer I already had. I'm using OBS Studio and Audacity for when I did just audio. Now I still use Audacity to clean up this audio. But I've got a Amazon mic arm. It's clamped to the table. I've got a capture card I have a Nikon DSLR camera that's taking this. It's into a capture card. I've got a USB adapter for my XLR mic. And besides that, it's like watching YouTube videos and asking people and how to podcast. And it's not easy. I can tell you, you don't just stick a mic in front of your face and do it. I'll be editing this video, at least the sound, to clean it up. I'm in my basement, so I have a furnace. Like, if you guys could see, I want to be able to pan my camera or have a couple up so I can give you guys alternative, views. But right here, it's a closet, a door I put, and there's a furnace right there. I've got a fridge, like right here. The 3D printer's running. It has fans. The 495 DC Beltway is like, 100 yards that way outside my door. So there's a little bit of background noise. You got to edit that out. You got to clean up the vocals. There's a lot of stuff you got to do. And then you got to put it on your feed website. And then it goes out from there to all your other platforms. And, it's a lot of work. It's not I thought it was going to be easier, but I'm enjoying it, and I'm not in it for the money. I'm in it to share some experience and knowledge, maybe help somebody. Even if I do 1,000 of these and I only help one person, it's been worth it. And I get to do some fun stuff on my off time. That's about it, guys. It's we got 1:05 a.m. and I'm going to sign off here, but I thank you guys so much for anybody who downloads and who listens. And if you do like what you're hearing, we always say just go over to any of our social medias, Facebook, Instagram, YouTube. Give us a like, give us a follow, share, subscribe, all of that good stuff. We hope to see you again, guys. Thank you.